All right, so Unit 2, Section 11, comparing measures of center. So now we're going to put the mean and median together, and we're going to compare the two of them together. So as we have learned, the symmetric distributions are summarized using mean, percenter, and standard deviation, while skewed distributions use median and IQR. So again, symmetric uses mean and standard deviation, while your skewed distributions use median and IQR. So we're going to look at both of these. So we're going to do symmetric distributions first on this screen. So they want you to find the mean. So if you want to find the mean, which is your X with a bar above it, you basically need to add all of these up. So add all of these up. So if you get out a calculator, I'm not going to write all these numbers on the screen. You just need to basically add all of those up. And if you add all of those up together, you're going to get 422,000. And then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. Oops, divided by 10. That's going to give you an average of $42,200. So that average right there is going to give you a mean of $42,200 for your mean. So a mean, the standard notation for mean is X with the bar above it. So on the next screen, we'll do median with the same numbers. So for the median, we're going to do the same thing. There's 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So remember, if there's an even number, 1, 2, 3, 4, 5, it's going to be the middle one between these two right here. So it's going to be the middle one between the 36 and the 40. So you're going to average the 36,000 plus the 40,000. So your median, divided by 2. So my median is going to give me 38,000 for my median. That is going to be my median value for my salary for the dental office employees. So now they want you to include 2 dentist salaries. So we're going to do these separately. So they want you to find the new mean. So basically you need to take your old mean, which your old mean was the 42,000, or sorry, your old mean, which was the 422,000, and add your 2 new dentist salaries, which was your $310,000 salary. Oops, another 0. And now you're going to have 732,000. And you're going to divide that. So now that there's 12 employees in your office, and that's going to give you an average of 61,000 per employee. Whereas for your median, your old median was the middle. If you put them in order in your middle, now if you line them up, so that one's going to be a little bit harder, but if you put all of your values there, your middle basically is, I'm going to have to kind of rewrite these. So you're going to have your 16, your 25, your 31.5K. Let me rewrite it. I'm going to write it vertically. It might be easier to do vertically. So you have your, your 16,000, your 25,000, your 31,500, 32,000, your 36,000, your 40,000, your 40,000, your, let's see, let me make sure, 62,000, 25,000, 31,500, 32,000, 36,000, 2 40,000s, a 62,000, a 65,500, 74,000. Now you've added 150,000. Oops. 160,000. So now your middle, since there's 12, 1, 2, 3, 4, 5, 6, your middle is going to be right here in between these two. So your middle average, oops, your median average is now 40,000. So you went from your median being here to it's now here. So it's no longer here, it's moved down one spot. So that is your new median and your new mean. Okay, so C says which measure, your mean or your median, was not changed by the inclusion of the higher salaries. Explain why it didn't change as much. So your median was not changed by much. Was not changed as much. The middle two numbers, shifted since there were extra values. Oops. Extra values. But did not see as, oops. Much of a dramatic change as the mean did. The mean was a lot bigger. The mean went almost about 20,000 versus going up like a little bit. So which measure was affected quite a bit by the inclusion of the higher salaries? So, oops. So your mean increased by almost $20,000. Oops. That should probably be capitalized if I'm starting a new sentence. Okay. So the mean calculation includes adding all the values. So it increased quite a bit by adding the much higher salaries. So when you added those much higher salaries, that greatly affected the mean. The median, it did not affect as much. Okay, suppose we want to compare the commute times for two cities, Austin and Houston. The following sample of commute times for workers who live in Austin. So they give you 15 for the first one. So since there is an odd number, you're going to find the middle one. So 1, 2, 3, 4, 5, 6, 7. And so if I go 7 up, and then this 20 is going to be my middle one. 1, 2, 3, 4, 5, 6, 7. There is my middle one. That's going to be for my median. And then for 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's my middle. Okay. So if I want to find the mean, I'm going to have to add all of these up and divide by 15. If I want to find the mean for this one, I'm going to have to add all of these up and divide by 20. So to find my mean for Austin, we're going to have to add them all up. I get 337. So to find the mean, you're going to have to add them up and divide by 15. And that's going to give me 22.5 minutes. Whereas my mean for Houston is going to give me 605. Divided by 20 gives me 30.25 minutes. That's supposed to look like a 3. So to find my mean, again, you add all of these numbers up on a calculator and divide by 15. And then to find my mean for Houston, you're going to add all of these numbers up on a calculator and divide by 20. So add all of them up. So you're going to add your numbers and divide by the total. Okay, and that's how I get those. And then my median, you're going to find the middle. So my median for Austin was 20. My median for Houston is 20. So you'll see the median for both of those is the same. So on the next screen, they want you to mark the median and the mean for both of them. So we're going to write those on the next screen. Okay, so on this screen, they want you to mark the median and the mean for each one. And so if you remember for Austin, it was 22.5 and the median was 20. The mean for Houston was 30.25 and the median for Houston was 20. So I'm going to mark those on the screen. So my mean for Austin was 22.5. So that was about here. So that's my mean. And then my median was about 20. So this is 22.5. So my mean was a little lower. And then here there's my median, and then my mean is a little higher for Houston. So you just got to draw those kind of on the picture. Okay, maybe that was that's kind of a bad eraser. Okay, D says, in one city, the mean and the median commute times were fairly similar. The other city, they were quite different. Explain what caused the difference to be so much greater for that city. So your mean, so the mean and the median, I'm going to try to write the best I can. So my mean and my median times were different in Houston due to the strong skew right effects. So if you look at the graphs for the commute times for Houston, you'll notice that you have more outliers on the right. For those, you've got outliers on the right in Houston, oops, they have an effect on the mean, but not on the median. Since the middle is still down with most of the data. So you have a few outliers in Houston, a few more outliers in Houston that are pulling that mean up towards those outliers that are making that spread out farther. So Austin doesn't really have as much outliers pulling that mean up. Houston has more outliers that are pulling that average up. Okay, suppose a business analyst who works in Dallas is commuting to a regional office for a company in Austin. Her commute time is 3 hours, 180 minutes. A high outlier, okay, is added to the Austin data set. The numerical summaries for Austin commute times are shown below. Both the original data set and the expanded data set is included. Okay, so they're giving you this information here. So look at this data set here. So they're giving you the original one and the expanded one. So let me add in this. Hold on a second. Okay, so I want to know the mean and the median were similar in the original data set you found. They want to know how did the outlier affect the original, or sorry, how did the outlier affect the mean commute time? So the, okay, it would help if you could see it. So the outlier, okay, so you'll notice that here's, without the business analyst, here is your mean and your median, okay? So you'll notice that your mean and your median are pretty close together. So the closer together that your mean and your median are, the more symmetric your graph is, okay? So, but what happens when they put the business analyst in here? That mean got pulled farther away from your analyst. So once that business analyst was pulled in there, that mean got pulled farther away from the median. So the outlier greatly affected the mean. It pulled, that's L's, it pulled the mean farther away from the median. But the median doesn't change. So the median doesn't change, it just pulled the mean farther away from the median. All right, now look at our measures of variation, standard deviation and IQR. Which was most affected by the outlier, okay? So if we look at the outlier, the IQR went from 20 to 25 and my standard deviation went from 15.23 to 42.04. So if our mean changes a lot, the standard deviation is going to change a lot. So it was our standard deviation. Okay, so if your mean changes a lot, then standard deviation changes a lot. Standard deviation will change. Okay. And then it says, why was the other measure not affected? So the IQR represents the middle 50% of the graph, which doesn't include the outliers. And the outliers are usually the problem that causes the changes in the mean and standard deviation changes. So that's the problem. So the IQR is not affected by that, whereas the standard deviation and the mean are. Okay, so in summary, the mean, is pulled away from the center by skewness or outliers, while your median is not affected. So then your standard deviation can strongly be influenced by your skewness or outliers, and your IQR is not much affected. So this main screen, this you really need to know, okay? Because you are going to have questions if I'm going to give you the test versus them giving you a MyMathLab test. I don't know what kind of test they're going to give you yet, but if it's going to be my test, you're going to have several questions where I'm going to ask you, like, if your graph is symmetric, are you going to have to use mean and standard deviation? But you should basically know if it's a symmetric graph, you're going to need to use mean and standard deviation for your center and your spread. And if it's a skewed graph, it should be median and IQR. So remember that your mean measures your center and your standard deviation measures your spread. If your graph is symmetric, so remember, if it's symmetric, it looks like that. And then median measures your center when your graph is skewed, and if it's skewed left, or if it's skewed right. And IQR represents your spread or your variation for your skewed graphs. So that is a main thing that you need to make sure that you learn that, because you will be asked that if I'm able to give you my kind of test and they don't give you a standard department test. And I won't know that probably yet for another week or so. But make sure you know that. Okay, before you do the next slide, I'm going to add in something that's not in your notes, but this is going to help you answer the questions on the next page. So if you have a symmetric graph, okay, if this is symmetric, okay, basically your mean should equal your median. That's mainly what you need to look for, that your mean will equal your median. If you have a graph that looks like this, where you have your outliers down here, or think of it like your tail down here, this is basically a skewed left graph, okay? Your median will be somewhere over here, somewhere near the hump, but your mean will be lower. So your mean is going to be pulled towards your outliers. So your mean is less than your median. That's the main thing to know. If you have a graph that is skewed right, that means your tail is down here, your outliers are down here, This is skewed right. Okay. That means your median is somewhere over here. But your mean is pulled over here. Oops. Let me erase that. Oops, let me put this black line here. But your mean is pulled towards your outliers. So your mean, it's a bad M. This time your mean, oops, your mean is greater than your median. Your mean is going to be bigger because it's pulled up towards your outliers. So that's the main thing to know on this page when you're trying to figure out how to compare if you don't have actual data and you're just looking at a graph trying to figure out whether your graph is skewed left, skewed right, and how to know which graph it is. Okay, on this graph, you're really not given much. So the main thing to do is to kind of figure out the shape. I'm going to kind of look at these graphs. I'm going to kind of go like this. Okay, and I'm going to kind of figure out. So it looks like the middle one is more symmetric than anything. I'm going to look at the middle one, my number of kids. This one looks more symmetric. And if I look at my table up here, my symmetric one should have my mean and my median close together. So this middle one is going to be day one because this is the closest one to having my mean equal my median. So this first one is going to be day one. Okay, so that's this one because they're the closest together. So this one, I have more of a tail on the left. So this is skew left. So that means that my mean should be smaller than my median. So if I look at these two, this one has my mean smaller than my median because my mean has been pulled down closer to my tail. So this one's going to be day 3. Oops. Let me flush this. Because my mean is smaller than my median. And then this one, you kind of have your medians pulled up. So my mean is greater than my median. So this is day 2. So that's kind of how you tell, you look for where more of your tail is kind of like. Okay, suppose there'll be 5 quizzes in a course you're taking with a score ranging of 0 to 100 points. Your professor will either use your mean or your median of your 5 scores when calculating your course grade, whichever is higher. Your goal is to earn at least a B 80% or higher for the score portion of your course grade. Suppose that you score a 65 on the first quiz and miss the second quiz, meaning you earn a 0. So you can earn a quiz median of can you earn a quiz median of at least 80 at this point? Explain why or why not, or show the scores that would make this work, including a 65 or 0 already determined. So at this point, I have a 0 and I have a 65, okay? So if I want to earn at least an 80%, okay? The minimum that I need to have on this is 80, right? So I can earn anything higher. So I could earn 80s on the rest. I could earn 81s on these. I can earn anything higher on the other ones. So this middle one has to be an 80. So as long as the remaining scores are 80 or higher, the median will be 80. oops. Why did I write this up here? Will be 80. Okay. So the remaining ones have to be 80. Because if it's anything lower, then that middle one is going to be 80. So then it says B, what is the highest quiz mean that you can earn at this point? So right now, what is the highest quiz average you can earn at this point? So if you have a 0 and you have a 65, okay, and then you basically get 100 on everything else, okay? So that's the highest possibility that you could get on everything else. So if I got hundreds on everything else and I divided by 5, the highest I could possibly get is a 73 average. So the 0 has a big effect on your average. So the median in this case would be a better grade, average would not.